Right, we are recording. Let me know what questions you guys have. What do you want me to go over? Don't you all ask at once. Well, while you're figuring out what questions you want to ask me, which you definitely should, let's do difference quotient. So what we'll do is we'll ask you, I'll do the 1-4 worksheet number 21 for the difference quotient. And they want you to, if f of x is x squared minus 2, then what they want you to do is find the difference quotient. You don't have to have this memorized. We will ask you find f of x plus h minus f of x all over h. And so what you're going to do is everywhere where you see this x, you're going to plug in x plus h. So we have that the function is x squared minus 2. And so that we're going to plug in x plus h there. So we're going to plug in an x plus h into the x. So this whole thing right here is the f of x plus h part. And then we're going to subtract from that f of x. So this whole thing will be subtracting f of x. And for subtracting f of x, you're just going to replace the function's value, which is x squared minus 2. And then we have all over h. And then what you want to do is expand out the x plus h squared, which always becomes x squared plus, if you're bad at expanding that, make sure you write it twice, right? X plus h times x plus h, which ends up giving you an x squared plus 2hx plus h squared. Don't forget you still have the minus 2. And then I'm also going to distribute the minus sign here and here. So we'll have a minus x squared, and subtracting a negative 2 will give you a plus 2. And that is all over h. All right, now, at this point right now, anything without an x in it should not an x, anything without an h in it should absolutely cancel. And so x squared minus x squared, those cancel. Negative 2 plus 2 cancels. And the reason why I know that that is going to happen every time is that I also know that the h in the denominator is absolutely going to cancel with an h upstairs every time. So you factor out an h, and you'll have 2x plus h left over, and it's over h. These two h's cancel, and your final answer here is 2x plus h. So there's an example of the difference quotient that will be on the test. Talk to me. What other questions do you guys have? Mapping questions. Okay. So how about, same worksheet then. I'll do the 1-4 worksheet. And how about, let's do number 4. So they give you this mapping where they give you the x values are 4, 0, and -4. They're in this like little bubble thing. And then the y values they give you are 7, 9, and 11. There's that. And then there's an arrow from 4 to 7. There's an arrow from 4 to 9. There's one from 0 to 7. There's one from 0 to 11. And then from -4 to 9. Okay, so that is what we call a mapping. And what you do is this. So first of all, your domain is one of the things I asked you, right? They want domain, range, and if it's a function. Okay, so the domain is going to be the set of x values, which were -4, 0, and 4. And then the range, so you don't repeat yourself. You know what I want to do here? Let me do this. What does this mapping mean? This mapping means that I have these points. I have when x is 4, y is 7. I have when x is 4, y is 9. I have when x is 0, y is 7. I also have that when x is 0, y is 11. And then I have when x is -4, y is 9. So the mapping is just a way to organize it, right? It's just another way to display it. I think I got all of them. 1, 2, 3, 4, 5. 1, 2, 3, 4. Yeah, okay. So here's the ordered pairs that this mapping just gave me. And so you don't repeat yourself, right, though? So the range is the y values, 7, 9, 11. And then, is this a function? To be a function, the x values cannot repeat to be a function. And if you notice, when I listed out all of the ordered pairs, there's 2 4s, and there's also 2 0s for your x values. And so this is a no, not a function. Now, one other thing I want to point out, like you also saw mappings like the same worksheet, but number 2, if they don't use any of the numbers in there, you just don't include them. So like the same thing, the 1-4 worksheet number 2 was, you had these values and these values, and I shouldn't have drawn those yet. So the x ones, you have 1, 2, 3, and 4. The y values were A, B, C, D, E. And there weren't any arrows pointing to D and E. They went from 4 to C, and from 3 to B, and 2 went to A, and 1 went to A. And so for here, think about, you know, here's one thing, and then there's another one. Think about how, if you were to write them as ordered pairs, it would be 1 goes with A, and then 2A, and then 3B, and 4C. And that'll help you determine what's the range and what's the domain. The domain are your x values, so the domain is the set of everything in that first bubble, 1, 2, 3, 4. But the range is not, you don't include the D and E because they weren't included. Even though they were in that list of y's, they weren't used, and so you don't include them in the range. You only do A, B, C, and that's it. So those were the only ones we did. And then is this guy a function? You want to say, do the x's repeat themselves? So we have an x, we have a 1, a 2, a 3, and a 4. So this is a yes. Even though we reused A twice, it, you know, the y values can repeat and it'll still be a function. All right, hopefully that makes sense on mappings. You guys just went cray-cray in the typing of the questions. Oh my. All right. Can I please have number 7 on the quiz? Number 7 on the quiz. All right. Quiz number 7. So it says the temperature at which water freezes is 0 degrees or 32 degrees Fahrenheit. So 0 degrees Celsius or 32 degrees Fahrenheit. Those are equivalent. And the temperature at which water boils is 100 degrees Celsius or 212 degrees Fahrenheit. Use this data to find a linear equation that expresses Fahrenheit. We want Fahrenheit as a function of Celsius. So how I always think about this is that, you know, when you see y equals f of x, you say y is a function of x. And so that helps me match up that Fahrenheit is going to be my y value and Celsius will be my x value. So when I write an ordered pair like x comma y, instead I'm going to be writing it as Celsius comma Fahrenheit. And so that means I've got 2 points. I've got 0 Celsius with 32 Fahrenheit, and I have 100 matched up with 212. And so we've got 2 points. You need to find your slope first. So your slope would be 212 minus 32, so it's the change in the y values, over 100 over minus 0, and I didn't grab my calculator, which I could probably do this in my head, right? What is that? 180? 212 minus 32 is 180. 180 over 100, which that means the zeros cancel, and 2 goes into both of those, so that would be 9/5. So your slope is 9/5. And then we want it as a function. You could do point slope form, or they actually give you the y-intercept there, right? So y equals, nope, I don't want y. I want Fahrenheit as a function of Celsius. So f is my y, so it's Fahrenheit is mx, so 9/5 times, instead of x, I'm putting c for Celsius, and then my y-intercept is 32. So I used this point right here saying that's my y-intercept because the x was 0. You also could have done, so that was your answer. That is f as a function of c. You would have gotten the same thing had you used point slope first and then converted it. So, okay. Finding the range in general, yes. Finding the domain and range given problems, yes. Okay, so I'll go over those. The problem is that you guys have typed so many questions that you need to stop asking questions for a minute until I can catch up to where we are. Oh my goodness, otherwise I'm not going to catch everything else. Okay, so we did that, finding the range and domain. Okay, so let's talk about domain first. Domain is all real numbers. That is going to be your answer unless 2 things happen. The first one is that you can't divide by 0. So if there is a variable in the denominator, then you need to set the denominator so that it cannot equal 0 and then solve for your variable. The second case is if you have a variable in the square root. Square root or fourth root, odds doesn't matter, but odd roots don't matter, like a cube root, there's no restriction on that. But on a square root, you need a positive number, and so whatever is under the radical, so the part that's under the radical, so that little square part that I put on there must be greater than or equal to 0. Because if it's negative, then you're finding an imaginary number. Okay, so that's domain. So for example, if I've got, let's see, but did we have any good ones? So for the quiz, those were good ones, right? So quiz 11. 11a was f of x equals 2 over x cubed, and that is, you've got a variable down there in the denominator, and so your denominator cannot equal 0. So we've got x cubed cannot equal 0, and then you solve for x, so x cannot equal 0. I'm fine with this notation. I'm pretty sure Mrs. Fox and Mr. Barker are also fine with it. Technically, or your book gives that the domain is the set of x's such that it means all real numbers except x cannot equal 0. So, but I'm fine with just you writing x can't equal 0. Part B on number 11. So number 11b was g of x is equal to the square root of x over 3. And so for this one, you've got x underneath the radical, and so under the rad, which is just x, must be greater than or equal to 0 is going to be your domain for that one. Had it been 3 over rad x, so let's just throw out another example here. If you've got 3 over rad x, you've got both of those domain issues happening, right? We've got that the denominator can't equal 0, so that means rad x can't equal 0, which if you go to solve that, that means x can't equal 0. But then also you've got a radical, right? So under the rad, so this part also needs to be greater than or equal to 0 to satisfy the radical parts. So both of these things have to be true at the exact same time, and so when you put them together, your domain will actually be that x must be strictly greater than 0. Right? To be under the radical, it can be greater than or equal to, but then because it's in the denominator, then it's got to be strictly greater than. All right, then let's switch to range. Range is harder, for sure, but some things you're going to look for range. Range, well, the first thing is if there is no variable in the numerator of a fraction in the numerator, so that's the top, right? Come on, why are you not writing? In the numerator, if there's no x up there, well then y will never, ever, ever equal 0. Other things, if you've got, let's see, y equals the square root of something, what's underneath the rad has to be positive, greater than or equal to 0, which means that y must be greater than or equal to 0. If you've got y equals absolute value of something, right? It doesn't have to just be an x. It could be an x plus 2 or whatever. Same thing. You're taking the absolute value of it, so y is going to be greater than or equal to 0. If you've got y equals something squared, or an even power, y must be greater than or equal to 0. I'm trying to think if you're going to see anything else. If there's a cube, it's all real numbers, like x cubed, anything cubed. You can have negatives and positives. Okay, that should do enough. But if there's a fraction, you want to look at the top the numerator and the denominator. So 11a was f of x equals 2 over x cubed. So the range are your y values, right? The x cubed in the denominator, we know we're never going to plug in a 0 into x because that's not allowed. But I will get out both positive numbers and negative numbers, right? I'm going to, when you cube a negative number, my y value is going to be negative. When I cube a positive number, my y value is going to be positive. So I'm going to have both positive and negative y values. The only thing here that's causing an issue is this number up top right there. Y will never, ever, ever be able to equal 0. So your range, which are your y values, the range is going to be that y will never equal 0. And then part B for the range was g of x is equal to the square root of x minus 3. Okay, so we got that the domain for this guy was x was greater than or equal to 3, right? So your domain, you're plugging in values to where what's underneath the radical, this guy here had to be greater than or equal to 0. You're never going to get a negative number under there because it would be imaginary. So when your y values, they're taking the square root of something that is 0 or bigger, well then your range is going to be that y is greater than or equal to 0. Okay, so that was range, finding the domain and range, I got that one. And 14 on the worksheet. Okay. I guess I should scroll down in case there's any kind of error happening. Okay, no more typing any questions until I get through the list that's already there. Otherwise, I'm going to miss questions that you guys are asking me about what I'm doing. Okay, so 14 on the worksheet. Okay, 14, domain and range. Okay, so this is one for worksheet number 14. So this is the f of x is equal to the cube root of x and then minus 3. So it's definitely helpful to picture it. It's also, look at what kind of restrictions we have. There are no restrictions. Nothing that I just listed on what you're looking for domain and range is happening right now. Domain is all real numbers unless there is a denominator variable down in the bottom. There is not. There's not even a denominator here. And then we don't care. Like there's no restrictions on a cube root, right? I can take the cube root of negative 27 is not undefined, or it's not an imaginary number. It's actually negative 3. So not a big deal to have an odd index when you're doing radicals. So there are no restrictions on the domain. The domain here is all real numbers. And then range, same thing. Like you're plugging in all of these values and you're spitting out negative values and positive values. I mean, yeah, the whole graph got shifted down 3 units, but it's still all real numbers. The cube root function looks like this. That's the parent graph of y equals the cube root of x. And so the only thing that happened was it got shifted down 3 units, but so what? It starts here and it goes up and it comes down, and there's no asymptotes on here. There's no restrictions. It just keeps getting bigger and bigger and bigger and smaller and smaller and smaller. Very slowly, mind you. It's going to take a while, but it will reach all real numbers. Hopefully that makes sense. I can't even scroll down to see if it does, so sorry. Okay. Can you explain how to do the dilations and compressions for the different parent graphs? Yes. All right. So let's do an easy one. Like if we have y equals x squared, here's the parent graph of the parabola. right? And so what we know is when you plug in a 0 into x, you get y is 0, and when you plug a 1 into x, you're going to get y is 1. When you plug a negative 1 into x, you're also going to get a positive 1. When you plug a 2 into x, you'll get a y equals 4. So 1, 2, 3, and 4. Yeah? So we got 2, 4, and we also have negative 2, 4. Okay, so here's this regular parent graph of a parabola. So what that means for us is if I want to get another point, let's say I've got my vertex at 0, 0. From the vertex, how did I get another spot, another dot on my graph? Well, there's lots of ways, but you can kind of think of it as, for lack of a better word, slope, right? It's not really, but from the vertex, to get another point on my graph, I went right 1, up 1, and I got another dot, right? So I'm going to write that, right 1, up 1. And then to get another dot, I went right 2, up 4, another dot. So right 2 brought me to up 4, yeah? Because 2 squared is 4. You can do the same thing of, if I went left instead, it's just looking at the positive ones, it's easier. Okay, so now, what does y equals, let's do 1/2 x squared now, okay? So if you were to do an xy table, right, 1, 2, and 1, and 2, 1, 2, 3, 4. Okay, so if you do an xy table and you plug in 0, all right, you're going to get 0. What happens when you plug a 1 in? You plug 1 into x, and you get 1/2 times 1. So you get a 1/2 for your y value. And also when you plug in a negative 1, you're going to get a 1/2. When you plug a 2 into x, you would get 2 squared is 4, but then times 1/2, and so you only end up with a y value of 2. And same thing with negative 2 will also give you a 2. So this is much wider, right? And what we did was from the vertex, we went right 1, up, not 1, but we went up 1/2. And right 2, I went up, not 4, I went up 2. And so how were these related? Here to here, and then from here, a 1 to a 1/2. It had to do with 1/2 times the y values, right? You multiplied 1/2 by the y values. And so I'm showing you this so that way when you're working backward, and instead of us giving you the equation, if you're given the graph, what you want to look for is, look, I went from the vertex right 1, up, okay, it looks like 1/2, I'm not sure, so let me check out the other one. I can tell that it's like in between 0 and 1, but I'm not positive. So let's look at 1. We really want to look at where they're crossing. On the test, we'll give you like the grid type graph, so you want to see where they're crossing a corner of a box. But from the vertex, I went right 2, up 2. Well, the parent graph is right 2, up 4. So right 2, up 4, when you take 4 and you multiply it by 1/2, that's going to give you the 2. And so that's the value that that's your, if you remember from last year, your A value, the number that goes in front of, the x squared problem. If you're describing it, 1/2 in front there means it's been compressed when it's a fraction by a factor of 1/2. And I ran out of room on this slide, but I can do the same thing with what is a stretch. You're going to get a stretch when the number in front is bigger than 1. So if it's a 2, if you had like y equals 2x squared, that means it's been stretched by a factor of 2. It's skinnier. It's because all of your y values got multiplied by 2. And so you would still have 0, 0, but when you plug in a 1, you're going to get 1 squared is 1, but then times 2. And same thing with negative 1. You're going to have positive 2. When you plug in a 2, you're going to get 8. So this guy is way skinnier. So we say it's been stretched by a factor of 2. It's like you take your arms and, ooh, it got skinnier. And so that's dilations, compressions. To me, that means the same thing, dilate or compress. Stretching is when it's skinnier. Okay, so number 13 on the quiz. All right, quiz number 13 is the greatest integer function. I think you should use transformations, right? G of x equals greatest integer function of x minus 2. So let's remember that the parent graph of this guy looks like closed dot at 0, and at 1 it's open, and then connect. And then when x is 1, your y value is 1, and it goes all the way to 2, but then open dot, and at 2, your y value is 2, so it jumps up. And then same thing down here, open, closed, negative 1. Okay, so now what have we done? We have taken this graph, and this means shift it right 2 units. All right, so instead of, I like to start with this guy right here. It makes it easier, I think, anyway. It got shifted 2 units to the right, which means I'll have a closed dot here at 2, and open here at 3, and then all of the values in between. And then the next one was just a single jump up, so a closed, open, and then I would follow the pattern down and just go, okay, that's open, closed, connect the step, open, closed, connect the step, open, closed, connect the step. It's like that. And what happens if there's a 2 in front? If there was a 2 in front, you would have to find a few values, right? So a 2 in front would make all of the y values multiplied by 2. So if there was a 2 in front, so if had it been g of x equals 2 times this guy, your x values stay the same. Your y values get multiplied by 2. Multiply y values by 2. And so that just means, all right, so my original spot, my y was 0, so that guy still stays the same. But on this next one, the next step up, instead of my y value of 1, I'm going to have a y value of 2. So here's that step. And then here at negative 1, I need to multiply it by 2, so now I'm down at negative 2. So close dot here, open dot here, and then the next step would be a negative 2, but I'm multiplying it by 2, so that means you would need to go down to negative 4 for this. Oops, I should have written it on this side. Negative 4 for that guy, so close dot and then open dot on that side. I don't think you're going to see something that complicated. It can happen, but I think we're going to be nice to you on that one. All right. Do you include any y values in the range that aren't paired with an x value in the mapping problems? Nope, you don't, Diane. I did that one, but I'm sure you probably asked that while I was doing it, Katie, but I couldn't scroll down. Can we do number 8 on the quiz? Okay, I did the difference quotient type as the very first example. So if we have time at the end, I'll come back and do that one again. do number 11 on the quiz. I just did that one. Good. So the rule of thumb is that you can't repeat numbers. So Justin K, if what you're saying, you probably were asking me a question on a few slides ago. When you say the rule of thumb is that you can't repeat numbers, I think you're talking about when you're listing the domain or range correct. Even if they repeat themselves, you don't write them more. You don't repeat yourself. You just list out what are the actual x values in the domain. And then if the x's repeat themselves, it is not a function. All right. Could I graph f of x equals Isabella Frith? If that's an x divided by x squared minus x minus 2, you're not going to see something like that. X divided by x squared minus x minus 2. Yeah, no, you're not. No, we're not going to do that one right now. Page 62, number 27. Okay. So here's page 62, number 27, and they're giving you that f of x is x cubed minus x over x to the 5th plus x. And they want to know, is this function even, odd, or neither? All right, so remember, this is when, to find if it's even, odd, or neither, what you're going to do is plug in a negative x. And you're going to see what happens. So that means everywhere you see an x, you're plugging in a negative x. And then you're going to simplify. Negative x quantity to the 5th, and then plus a negative x. All right, we simplify this. A negative x cubed stays negative, right? When you bring it to an odd power, it's going to be negative. You're subtracting a negative x, so it becomes plus x. Negative x quantity to the 5th is a negative x to the 5th, and then plus a negative x would be a minus x. All right, so here's what we know. We know that if this guy, come over here, f at negative x, if it's equal to exactly what's there, then that's an even function. Even function is if you plug in negative x and you get exactly the same function, then it's even. You get an odd function if when you plug in negative x, you get negative f of x. And so at first glance on this, and then if you don't get either of these, then it's neither. So at first glance, you look at it and you're like, it doesn't look even, right? It's not exactly the same. And then, oh, maybe it's odd. I see signs changing, right? I see a negative x cubed and then a plus x. So the signs up top changed. Oh, but then the bottom is negative x to the 5th minus x. So the bottom ones changed too. What does that mean? Neither? No, what you got to do is simplify it. So I'm going to factor out the negative that's up top. And it becomes a positive x cubed and a minus x. I'm going to factor out the negative that's in the denominator so that it becomes a positive x to the 5th and a plus x. And then checkity check this. A negative divided by a negative becomes positive, and this guy is exactly the same as my original function, and so this guy is even. Crazy, right? As a side note, what will it look like if it is odd? So a negative f of x would either be, think about this, like when you write, I need room somewhere. If I say negative 1/2, you either have it in front of the fraction bar or you can distribute it up to the 1, but then the 2 is positive, or if you distribute it to the bottom, the 1 is positive, and then the 2 on the bottom is negative. It's never equal to, which you just saw in this previous example, a negative 1 over negative 2. Like, that's not going to happen, right? So you can either have, if it's a negative f of x, what will happen is you'll either have a negative distributed up top, which would be a negative x cubed plus x, but then the denominator stays exactly the same signs on both terms, x to the 5th plus x. Or it also could have been that the top stayed the exact same signs, so a positive x cubed and a minus x, but then on the bottom we changed signs. Either one of those will produce an odd, so minus x. These ones would have produced an odd function. And then if only like part of them change but not the other ones, then it would be a neither thing. But those are, that is how you handle that one. Can you explain number 4 on the quiz? I don't want to go into spend a bunch of time on number 4, but just what you do need to know about number 4 is that writing something as f of x plus a, like okay, so a is a number is all it's representing, right? So if I told you, what's f of x plus 2? You would go, oh, that's a shift left 2 units, right? And if I said, what's f of x minus 3? You would go, oh, that's a shift right 3 units. That's the kind of thing you need to know. So the answer to this one, what it was saying was, if it's symmetric with respect to the y-axis, here's an example of one. Your line of symmetry for the y-axis, that equation is line symmetry is x equals 0. And so now x plus a, this is a f of x plus a, means that it's a shift left a units. A is just representing any number, right? So now, instead of x equals 0 being my axis of symmetry, or line of symmetry, now it's going to be at negative a. Still it didn't have to be a parabola, but a parabola is an example of one that's symmetric with respect to the y-axis. And so now your line of symmetry is x equals negative a. The numerical greatest integer is like if I were to ask you, did you not have one on your quiz? Okay, so if I asked you, what is the greatest integer less than or equal to 78.1? All right, well, that's just 78. What's the greatest integer less than or equal to negative 78.1? Oh, that's trickier. Think of the number line. Yeah. So if here's 0, and then obviously I'm jumping way far, here's negative 78, because this is negative 1, and then the numbers get bigger as it goes to the left, right? And negative 79 is here. Negative 78.1 lands right here, and the greatest integer less than it is negative 79. So remember, it's not a rounding. It's not a, it's cut it off unless they're in the negatives, and then you're going further to the left. Okay, can we do 11A on the quiz? I already did it. Number 9. Oh, good one on the quiz, yes. All right, so this is quiz number 9. I feel like I'm rushing, but there's so many questions that still. Okay, number 9. We've got f of x is equal to 4x over 3x minus 2. And they want you to find the inverse. Definitely like this on the test. right? It's a much more complicated one, but you're in pre-calc, so you can totally do this. All right, so start off by changing f of x to y. And then we switch our x and y values. And then you want to solve for y. So here's why this is more complicated, is because you've got your y on the same side, you've got your x on the other side. The problem is that there's two y's sitting there, and you need one y equals everything else. So you kind of have to do what doesn't seem natural, and that is you got to separate your y's. So I'm going to multiply x times the 3y minus 2, and that's equal to 4y. Okay. And then that's equal to 4y. And then you're going to distribute the x so that you've got 3xy minus 2x is equal to 4y. Then you're going to collect all of the y's, any term with a y in it, you're going to collect it on the same side of the equal sign. So I would subtract the 4y. Nothing wrong with bringing them over to the other side, that would work too. But at least this way I have a positive 2x and a positive y to start. And then you're going to factor out the y that is in common, which then gives you a single y, which is fantabulous because now you can actually solve for y by dividing both sides. Once you have y times a single thing, it can be a complicated looking single thing, but the 3x minus 4, it has parentheses around it. And so, and then your last step, of course, is to write f inverse is equal to that guy. So that's how I wrote my answer. Nothing wrong if you would have brought your numbers over to the other side. So another completely correct answer is negative 2x over 4 minus 3x. That would work as well. All right, that was number 9 on the quiz. 11a I already did. Go over example of translation with the dilation. Oh, translation with the dilation. Okay. Translation with the dilation. So like quiz 3, number 3, both A and B. Quiz. So quiz, I don't know, number 3. Gave you an upside down V with a vertex of 4, negative 1. So there's the vertex. And then here's what you have to look for is not only that, but you know, the parent graph of y equals the absolute value of x. You start at 0, 0. When you go right 1, up 1, put a dot. Right 2, up 2, put a dot. And then same thing with left 1, up 1. Right? Left 2, up 2. So I guess I should write that. When you go right 1, you go up 1. When you go right 2, I'm going up 2 for the absolute value. Okay, but then for this guy, let's see, what other points can I see? It looks like it went doot and doot, doot. It looks like there's a dot going through the box. That one and that one. Okay. So we have a vertex, new vertex of 4, negative 1, right? That's what that guy is, which means it got shifted right 4 and down 1. That's a translation. Translation shifts, same thing. It's been translated 4 units to the right. It's been translated 1 unit down. Okay, and then where does the dilation or stretching come in? Well, what did I do? to go, I went from the vertex, right 1, down 2. From the vertex, I went right 1, down 2? Compare that to this. And so that's what's giving you that you are multiplying by a negative for the down part and then a 2 to bring, instead of up 1, I went down 2. And so that's a translation with also a stretch or dilation. I don't call those dilations, I call those stretches, but y equals, that's why there's a negative 2 in front of the absolute value, and then your left and right goes inside the absolute value symbol, so a right would be an x minus 4, and then a down 1 is outside of the absolute value symbol, so a minus 1. So that was your answer to quiz 3. All right. What's next? Page 47, number 4. I'm not going to do that one. That's more complicated than what you're going to see. What's the range of a numerical? What's the range of a numerical greatest integer function? I just did one. A numerical one is just the one I just did. So hopefully, I think you asked me that way before I did that one. Page 51, number 13 and 21. Oh, that's why somebody asked me to do that, number 13, and then I didn't do it. Okay. All right, we'll do that. Page 51, and this is number 13. They give you f of x is x over x squared minus x minus 2, and they want you to find the domain and range. Okay, so first of all, this denominator factors as x minus 2 and x plus 1. And so remember, domain, the rules are, domain is all real numbers unless you have variables in the denominator. Oh yeah, we got 2 of them down there. Or a radical. There's no radicals here. So all we care about for the domain is that x minus 2 times x plus 1, which is my entire denominator, that this guy can't equal 0. Well, that means x minus 2 cannot equal 0, and x plus 1 cannot equal 0. And so x cannot equal 2, and x cannot equal negative 1. That's your domain. Range, if it had only like a single x squared, well, even that, yeah, minus x and minus 2. Yeah, the range is going to be y is all real numbers. That's the range. There's no restrictions on it. And that's more complicated than what you're going to see. Number 22. Finding the inverse. I just did an inverse, but I think this might be your homework, huh? So maybe we'll do it real quick. Number 22. So g of x, I'm going to replace it with a y, is 1 over x plus 2. You're going to switch your x and your y so that x is equal to 1 over y plus 2. And then you're going to solve for y. Multiply both sides by the y plus 2. And then you've got to go x times y, because I'm going to distribute the x to both of these guys. So x times y plus 2x equals 1. Isolate the term with the y in it. So xy is equal to 1 minus 2x. And now you can divide the x. 1 minus 2x over x. And you should probably use inverse notation, which was g inverse would be 1 minus 2x over x. I didn't really go into the whole restricting the domain of the original, but technically, you know, x can't equal negative 2, which is where this restriction would come in for, I think the answer probably does that, don't they? Or maybe they don't. I don't know, but there you go. Oh, the book answer, I don't know if you have evens. I'll just leave it like that. Okay. I'm a little confused about number 22. More about the larger concept of restricting the domain of the original function. Okay, there we go. So that's what it is now we've talked about domain. What's the domain of the original? X cannot equal -2 because your denominator cannot equal 0, and -2 would make it 0, and so that's the restriction of the original. Don't stress about it. I don't think you're going to need to worry about it. I'm also confused about graphing stuff like 2 times f of x and 2. Okay, so this is what you need to keep in mind is no matter what f of x is, because we're probably going to give you some functified, you know, little, I could give you like some weird graph, like, I don't know, that, or, you know, I don't know. We can make up something like this, right? I'm going to remove that last part. We wouldn't make it that bad. And say, hey, this is f of x. How do you graph 2 times f of x? 2 times f of x means your x values stay the same. And the only thing that changes is you multiply every y value by 2. So what I would do if I was doing this problem is I would identify some fake-ish points, right? I don't know, if I say this looks like a 2 to me, right? Whoops. Let's get out of there. Okay, so that means this point would be like, I'm going to just make it up, -2, +2. And then this guy is 0, 2. And let's say this guy is 4, 2. Even if we don't give you actual points, you can just make up some that seem reasonable, right? Which means this guy looks like a, I don't know, -4, 4. Why not? I don't know. Okay. So if these are my points, right, that I'm making up, but that look reasonable, that will help me graph my graph. So the point -4, 4 for f of x, if that's a point on f of x, 2 times f of x will be the x value stays exactly the same and the y value gets multiplied by 2. And I have the point -2, 2. X value stays exactly the same, the y value gets multiplied by 2. 0, 2. X value stays exactly the same, y gets multiplied by 2. Hopefully you're seeing the pattern. X value stays exactly the same, y gets multiplied by 2. All right, so then you just graph those, and it's just going to be a, you'll be at 4 instead of 2, but that's going to still be a straight line. And then at -4, -8, it means this guy is going to be much steeper. Anyway, if you plot the points, it's hard to do it on this little tablet thing. So, all right, so that's 2 times f of x. Can we do number 3 on the quiz? What time is it? Okay, I just did number 3. Yay. Can we do number 4 on the quiz? We did it. Yay. Can you do number 8 on page 114? Let's see what that is. 114, number 8. Okay. So page 114, number 8. Wants you to graph y equals the square root of x minus 4 using a parent graph. Well, the parent graph is y equals the square root of x. And that guy is 0, 0 when x is 1, y is 1. 1, 2, 3, 4. When x is 4, y is 2. Notice I avoided all the crazy radicals in the middle. Okay, so here's the parent graph of y equals rad x. And then what does x minus 4 inside or under the rad? This is considered inside the parentheses, so that is a shift right 4 units. And so I need to come down here then, because 1, 2, 3, 4. Now, instead of 0, 0, I'm here, but I still go right 1, up 1, and then 1, 2, 3, 4, 2. Just from the pattern of that's what happens. So this is going to be y equals the square root of x minus 4. You can plug numbers in too, how are we going to know? But you're going to have to like describe what kind of translations happen. So, oops, okay. Okay, so that was number 8. Are we going to have to restrict the domain on equations that we solve for the inverse? I don't think so, Taylor. I don't think we're going to need to restrict the domain, which is why I didn't concentrate on that. Number 7 on the quiz I already did. Shift and translation, are they interchangeable? Yes. I always say shift, but it's truly a horizontal translation 4 units to the right, or a vertical translation 3 units down. Yeah, translation and shift are the same thing. All right, page, you guys need to, there needs to be no more because I'm going to finish the questions that are on here and then we are out of time. Page 47, number 6. Oh yeah, yep. Okay, we're doing that one. Page 47, number 6, is a piecewise function. So that g of x is x squared when x is less than or equal to 5, or just x if x is greater than 5. Oh, there's such huge numbers. Well, okay. All right, so we know this is a y equals x squared, which is a parabola. Yeah. But I'm only going to go from when x is 5, so it would be 525. Oof. So it's going to be from here and then forever in that direction, and I'm going to erase anything to the right of 5. And then we've got a y equals x, which is a straight line like this, but I'm going to only do it from 5, have an open dot, and it's going to be shaded all to the right. So putting those two together. All right, so let's say here's 5, and I'll say here's 25. So that means this parabola will be 5 here. We're going to go through 0, 0, so we know it's going to go, it's a parabola going like this. And then for x equals 5, let's say this is 5, I'm going to do an open dot here, and then it's got a slope of 1, like that. So it's like, the other thing you could do too is do an XY table, but you just got to make sure you include 5 in both of these guys, and then just that is an open dot, and then the or equal to here is a closed dot. So, okay. How do you find the inverse graphically? You flip the coordinates out, absolutely. Yeah. So this will be the very last one I do. Okay. If we do something weird like, I don't know. Let's go. I don't know, something like that, right? And so what you want to do is identify points. So let's say this is 0, 3. And then I'll say this guy is a, what does that look like? It looks like about a 5, 6. I don't know. And then here, let's say that's a 6, 0. And then let's say this guy is negative. No, not negative. That would be a, well, let's pretend like we jumped all the way to 7 and then it's a negative 2. I don't know. Okay, so how are you going to graph this? If this is your f of x, then your f inverse F inverse would be, if I have 0, 3, I'm going to have the point 3, comma, 0. If I have 5, 6, I'm going to have the point 6, 5. If I have the point 6, 0, I'll have 0, 6. And then if I have the point 7, 2, I will have the point negative 2, 7. All right, this is going to be interesting to squish in. I need to go as big as 6. Okay, so okay, so we got negative 2, 7. I got this point here. I've got 0, 6, so like about there. I've got 6, 5, which would be about here, and then 3, 0, about there. And so that means that the inverse would be, if I can draw a straight line, like that. Of course, it's all functified, but something along those lines. That's what you're going to do. You're going to identify points, flip the x and the y, and then graph it. All right, guys, I think that's it. Since we're out of time, it's 7:36. Good luck. You're going to do awesome. I am going to right now stop this recording. I'm going to post the link in this box, in this chat box right now, so that way those of you that are in here that missed the beginning, you'll be able to access the beginning part of the recording immediately. You are all very welcome. And then I am going to right now try to download it onto my YouTube thing. It's going to take an hour and 8 minutes to do because that's how long we were recording. And then I will send a text through Remind of the link to the YouTube video portion of it. And so everybody's got one. All right. Good luck, guys. See ya later.